All right. Happy Thursday, everyone. I think everyone knows what today is, right? It's National Knock Knock Jokes Day. Yeah, that's right. I'm glad you remembered. Yeah. Hey, Sam, I've got a knock knock joke for you. Knock knock.
Who's there, Mike?
Sam Rashkin.
I knew I shouldn't do this.
Go ahead, Sam Rashkin.
Sam Rashkin.
Yeah, Sam Rashkin who? I just wanted to get you to say that line. That was actually really nice of Sam to play along with me. He had no knowledge predetermined of that setup, so I appreciate Sam playing along with me there. But hey, speaking of this seminar that we're doing, we're going to be talking about the future today, and not just November, which starts tomorrow. We're going to be covering smart homes, disaster resistance, future proofing, all of that, and we're going to be joined by J.D. Gill of Schneider Electric, which is doing, Schneider Electric's doing a lot when it comes to smart home technology, and he's going to share a little bit more about that in just a little while. Now, back to the aforementioned Sam Rashkin. He is the former chief architect at DOE's Building Technologies Office, but now is focused on creating and teaching the content for the Housing 2.0 program. That content is based largely on Sam's book, Housing 2.0, A Disruption Survival Guide. The full program was established to help empower you, our building professionals, to design and construct higher performance, healthier, more sustainable homes at a fraction of the cost. Sam's going to lead today's seminar and also address your questions at the end. Now, before we get started, we have some sponsors that will probably make you smile more than even my bad knock-knock jokes. And the first is Schneider Electric, who is driving the digital transformation of modern homes with smart and sustainable energy solutions for ultimate comfort and energy efficiency. Their connected home ecosystem of smart energy management solutions provides digital control of energy use throughout a home, from the grid via their smart electrical panel to their connected wiring devices. Next, we have Jinko Solar. They are a leading PV module manufacturer and energy storage system integrator. The company has deployed more than 100 gigawatts of their Eagle modules in 160 countries globally, including more than 17 gigawatts right here in the United States. Eagle Storage brings together the best energy storage technology for turnkey hardware and energy storage services. We also have Panasonic Healthy Indoor Living Solutions. They are helping builders across the country differentiate themselves with powerful, code-compliant, and cost-effective indoor air quality solutions that provide a safer environment for home buyers. And finally, our newest sponsor is LG HVAC. As a leading proponent of the electrification movement, LG is proud to pave the way with arguably the broadest portfolio of home electrification products, from air-to-air and air-to-water heat pumps for HVAC, water heaters, clothes dryers, and washer-dryer combos, all the way to advanced energy storage systems, EV chargers, and super-efficient appliances, including the industry's first Energy Star certified induction cooktop. LG's innovation and technology will help us promote decarbonization and collectively create a better life for all. Now, during the course of today's presentation, you can submit questions for Sam and then later on JD as well. Simply use the questions box inside the GoToWebinar control panel. I'm going to review those questions and pose those to Sam and JD after their presentations. All right, here's the man who knows who he is. It is Sam Rashkin.
Just getting my mic on. Thank you very much, Mike, and great to be here like Mike. I'm incredibly grateful for our sponsors who make this unique content possible. This program is not kind of aligned with most building science and high performance home training. So their appreciation for how important it is to integrate the total user experience optimization with high performance is so much appreciated. So again, my thanks as well to Panasonic Schneider Electric, Jinko Solar, and LG Air Conditioning Technologies. Okay, I'm trying to get my, there we go. One issue I'm having, good, I'm good to go. So today, we're going to talk about Future Ready Matters. This is the third session out of 4 in our seminar series for this fall. And I'm going to begin with this quote. When we build, let us think that we build forever. My good buddy Mark LaLiberte uses this famous quote from John Ruskin to end all of his presentations, well, at least all that I've attended. And I'm going to put it at the beginning because it's so powerful about what we're trying to do as a building industry. Who we are is what we leave behind. So finishing his quote, "Let it not be for the present delight, nor for the present use alone. Let it be such work as our descendants will thank us for. And let us think as we lay stone on stone that a time is to come when those stones will be held sacred because our hands have touched them. And that men will say as they look upon the labor wrought substance of them, see, this our fathers did for us." And so this is such a great quote. I know Mark uses it every time. Buildings are truly an amazing endeavor. We, as I talk about all the time, are involved in where people spend 70% of their lives. So thinking about the future is really important. And what we're going to cover today is how to predict the visible future, prepare for the visible future. And then I got JD Gill from Schneider Electric with us. And very much a significant part of the future is getting to smart homes. And JD is going to be an incredible resource for how to do that so much more effectively and so much more aesthetically. So I'm real excited to have JD to wrap us up. And then we go into discussion at the end, as we do with all sessions. So let's talk about predicting the visible future. And I'll use a resource, a book by Daniel Burris called Flash Foresight. And it kind of states the obvious that we all know. Just our everyday lives, we're just confronted with just an incredible sense of change. In fact, the accelerating rate of change is as certain as the sun rising in the east. It's going to sweep across our landscape like the technological tsunami it is. It will disrupt catastrophically every aspect of our industry, except for those who see it coming. And effectively, Housing 2.0 is about really helping the housing industry see what's coming and just be prepared to deliver better homes for lower cost. So this is the visible future reality that we're in. And how do we prepare for the future? And so other key concepts from Flash Foresight, I think, are great. You can predict the future accurately. All you have to do is just leave out the parts you could be wrong about. That sounds like a joke, but it's true. The key is knowing how to distinguish between a soft trend from a hard trend. It's knowing how to recognize certainty. So for example, granite counters could be a soft trend, and we know there'll be something to replace it, quartz or something else, just like colors, just like many design trends, even locational preferences, many of those are soft trends. A hard trend is something that you know about with certainty. And those are what I want to speak about today, because if we recognize them, we can be better preparing for the future. So let's look at 3 hard trends I think every builder has to recognize, and every housing professional, in fact. And the 3 trends are more disaster risk, more water shortages, and this transformation to all electrification. And to be future ready, we simply respond to those hard trends and we're prepared. We're disaster ready, water ready, and smart electric ready. And that involves appliances, equipment, solar, electric vehicles, batteries. All these are our future. So let's figure out today how to start preparing for the visible future. Let's start with disaster ready. And so normal Housing 2.0 programs, the full curriculum, when we get to disaster ready, we lay out these key best practices. On the left, the first column is the high tier best practices to optimize disaster resistance and then optimize post-disaster occupancy. And then we have the more granular, detailed best practices for each. So disaster resistance is normally addressed with wildfire resistance, flood resistance, wind impact resistance, hurricanes, tornadoes, earthquake resistance, and severe winter weather resistance. And to be ready after disaster to stay in your homes safely and with comfort, we have high performance homes, have greater resilience, as do natural comfort homes. And then we have the various solar electric systems, solar hot water, battery storage, lots of ways that we can create persistence in our ability to stay in our homes. So this is the list. Let's talk more broadly about the imperative. So it's not so much a political reality. You know, a lot of times disaster gets connected to climate. There's a lot of political debates about climate and human impacts on climate. I'm saying just to look at the science and look at the data. And we all know this. Any of us who've been around for the past few decades, we've just experienced it. There are extreme weather risks. Disaster events have become more severe as the planet warms. The last 19 most hottest years on record in the last 20 years. 2023 is on track to be the hottest year on record last year. So we know the hard trend. We know the planet's getting warmer. We know that that's directly correlated to lots of disasters. So we have this rapidly accelerating risk. The world hits record land sea temperatures. And so when the ocean's 2 or 3 degrees warmer, I think the Gulf surface temperature, the Gulf of Mexico surface temperature last year was 100 degrees. You have to expect Helene and Morton and all these hurricanes. There's just insane amount of greater moisture being absorbed into the atmosphere, greater gradients of temperature. We're just creating all the conditions for much, much more significant frequency, magnitude, and expense of disasters. And so this is just where we're headed, and we all know this. And so let's first talk about frequency. 5,000-year rain events have struck the US in 5 weeks. Why? You know, I love this quote from this film, The Princess Bride. Inigo Montoya keeps listening to the guy say that it's inconceivable when things keep happening that he says are inconceivable. And the famous quote is, "You keep using that word. I do not think it means what you think it means." And I don't think we understand what the term 1,000-year event means anymore. When you have 5 of them in 5 weeks, it's a stunning, almost need for coming up with new ways to understand what is truly a 1,000-year event. We don't understand that term. It's just that much more severe what's happening. And so we have this accelerating frequency as well. Climate disasters daily, welcome to the new normal. We had over 4 times greater frequency of billion-dollar disasters when you control for inflation then since billion-dollar events were started to be recorded in 1980. The average time in 1980s between billion-dollar events was 75 days. Between 2018 and 2022, the frequency between billion-dollar events adjusted for inflation was 18 days, 4 times plus greater frequency. This is just the world we live in. And on top of that, we have the magnitude keeps getting greater. We have 6 times more billion-dollar severe storms during 21 to 2022 than during the previous 2 decades. So this is just the chart looking at the number of events and the exponential growth in the curve. But it's not just the magnitude of the cost, it's also the magnitude of the actual heat or storm or water surge. We used to get like 3 or 4 foot water surges in hurricanes and think that was incredibly disastrous. And now we get 13, 14, 15 feet walls of water coming at cities on the coast, and it just destroys every place they go. That much water is devastating. And so this is the magnitude we're talking about, 3 times faster sea level rise in the next 30 years compared to the past 100 years. And so we know all the sea level locations are at so much greater risk. And then the expense is accelerating. Again, this is a curve that shows 6 times more billion-dollar disaster events in 2023 than any year since we started counting in 1980. And then the expense, of course, comes along for the ride. Last week, we reported that Hurricane Milton caused more than $30 billion damage, and along with Hurricane Helene, it was $60 billion of estimated cost And so that's just in 1 week, essentially, just the amount of damage that's been done and expense that's been imposed by disasters. And there's nowhere to hide. The risk exposure is almost everywhere. When you look at basically where the billion-dollar events have occurred and map them out, you can see for flooding, wildfires, severe local storms, and droughts and heat waves and winter storms and cyclones, we're basically covering the entire country. And the net exposure is $6 trillion estimated market value for the 43% of counties in the US with high natural disaster risk. That's a huge amount that there's nowhere near enough insurance and FEMA resources to cover the risk. And so we look at just more data, more than 2.6 million homes face risk of wildfire damage, looking at just one disaster risk. And $1.3 trillion is a potential cost for reconstruction. Again, we're blowing away the resources we have available to make people recover from disasters. And what I'd like to do is visualize what risk looks like, just so we see it. So this is Boulder, Colorado, and it's located at the mouth of a canyon in the valley of the Rocky Mountains with a beautiful creek running through the middle of the town. And when I look at a picture like this, I just say risk. So I'll just superimpose a funnel on this. You have all these, massive Rocky Mountain slopes, all kind of funneling into this one little town. And to see it actualized, of course, there was a flood in 2013. There has to be, over time, storms coming through the Rockies that could be melting a massive amount of snow in the spring, or just have a tremendous amount of just downfall that's all being collected by those mountains. And like a gutter being drawn through that town, the creek is not even close to adequate capacity to carry the water that flows through. So you're living with greater risks, and as the insurance actuarial analysis quantifies that risk, of course, costs keep going higher and higher. So that's one concern. The other concern is that the disparity of exposure to the risk is that disadvantaged communities shoulder an outsized share of the economic burden. One, they're often relegated to the lower value locations that have higher risk, down at lower elevations near rivers and so forth. And often they're not able to finance the insurance costs needed to protect them from those higher risks of disaster. So when it comes to the when it comes to the entire risk exposure, we really have just a crisis among lower income populations. And so the result is this increasing unpreparedness. Homeowners say they're unprepared for potential costs. 26% was the number. I think that's actually low. Just the more I see how many properties are not covered after like Helene and Milton and all these events go through. And some of it's because we're going through now situations where these disasters are occurring in places that didn't really seem to have as much risk as they have now. The whole mountain Appalachian region of North Carolina was devastated. They never had a storm like that go through it as it did with Helene. And so the unpreparedness losses, when you look at flooding, just from Hurricane Ian, it was 10 to 17 billion. Wind was 23 to 35 billion of uninsured losses that happened. And again, mostly impacting lower income households. And the net outcome, of course, is that property values take a hit. In this one article, flooding risks knocked $7 billion off home values. And this is just going to continue to increase as the awareness keeps getting higher and higher where those risks are prevalent. $16 billion in home value appreciation, lost to home value appreciation the past 12 years just due to frequent tidal flooding. And the net outcome is a decreased willingness to buy in these high-risk locations. 75 to 80% of survey respondents would hesitate to buy a home exposed to flood risk, high intensity of other natural disasters, extreme temperatures, rising sea levels. It's just now, it's top of mind in terms of where people are looking to move and where they'll filter out properties. And then the net impact, of course, is to reduce property values. And the net outcome also is places are now being exposed to situations where they can't even get insurance, or they're down to maybe just one insurance provider. And so the risk is that as we have rapidly growing exposure to risk, historic increases in cost, and a challenging reinsurance market that wants to back up insurance companies, the insurance companies pull out. So try to get wildfire insurance in California, try to get flooding insurance in Florida. It's just kind of pile up into it, one massive crisis in terms of homeowners and just insurance. So the net, of course, result is higher costs for insurance. Just in North Carolina, 40% increase was filed last year. And I'm sure after Hurricane Helene, it'll just keep going up even higher and higher. It's just insurance companies don't have enough assets to manage the risk. And yet, if we are more responsive, if we understand the hard trend, if we know we are confronted with more and more severe storms, we can substantially reduce the cost of insurance by addressing the risk. So these are a little bit old FEMA cost numbers for being at premium, the premium for being 3 feet above the base flood elevation, at the base flood elevation 4 feet below. And you can see if I'm 3 feet above, my 10-year cost is $4,200, $4,300. If I'm 4 feet below, it's $95,000. So if the developer builder doesn't prepare for the future and doesn't build at the right flood elevation, they just added almost $100,000 of cost for the occupants over 10 years. And these are old numbers. I suspect disparity in the cost has gotten much greater. So we know what to do to manage these risks. If we have wildfire, we have best practices we cover in Housing 2.0. First of all, we have vents. Burning embers can enter through those vents, ignite the structural framing, and set the house on fire. Obviously, non-combustible materials can be ignited, so we care about materials we use for roofing, walls, deck, and fencing. Heat-resistant windows, getting rid of gutters that can collect debris that can ignite, chimney spark arresters, and also a hardened perimeter zone where you don't have plantings that can ignite and catch fire. We know the basics, and when you can see in this map on the upper left, all the areas are exposed to wildfire conditions. And when we look at what happens when we apply those best practices, we have, like in this case, a lone building standing after the Oakland Hills fire in 1991. And this building basically had non-combustible roof. At that time, in the 80s and 90s, almost every home in California was being built with wood shake roofs, effectively kindling because of the aesthetic preference. And this house had the tile roof. It had an unvented attic, so the embers couldn't enter. It had non-combustible decks, stucco instead of wood, and it had non-combustible stucco walls, and it had a hardened perimeter zone around the house. And effectively, in a sea of devastation from fire, you have one building standing. We know these best practices are really effective. For wind and impact, it happens just through very serious wind events, tornadoes, and hurricanes. We also know what to do. Design makes a big difference. Having square versus rectangular with long sides being almost effectively a sail trying to absorb all the force of the wind makes a big difference. Hip roofs are much more resistant to wind deflecting it than gable roofs, and also the level above base flood elevation. Roof details that are much more secure for fastening the roofing system, optimizing impact resistance with certain wall assembly choices, and also having a very strong continuous load path from roof to walls to foundation. And again, you can see all the areas that are exposed. And what happens when we apply these best practices again, Another case of a lone building standing. This was Hurricane Harvey, Mexico Beach, a famous picture, but essentially we had a spray foam unvented attic. So, and you notice there was also a hip versus a gable. And so essentially when you add spray foam, you like double the strength of the roof structure. Plus you don't have vents to let wind in and pressurize the attic and basically kind of destroy the structure. So the spray foam unvented attic was a huge factor. And then the hip roof we mentioned, and then the impact resistant materials. This house is built with insulated concrete forms. So it's basically, you pour concrete in the voids of these styrofoam blocks and create like a waffle concrete structure for your wall assembly. That's incredibly strong and resistant. And then you had a raised first floor way above the flood elevation. So the big surge, 6-7 feet of water, the house was able to withstand it. And the foundation had an incredibly strong design for the continuous load path. And the foundations were these thick concrete pilings that were incredibly strong and able to support the building. So you have a building standing. So this building should pay massively lower insurance costs, and the insurance system has to figure out how to do that. And then flood risk is so pervasive in the central of the country and the coastal areas and up north, particularly on the Rocky Mountains going east. So we really have to look at the locations that we decide to build buildings, get the level again to clear the flood elevation, but with the new flood maps that recognize the much greater severe risks of flooding. And then we have various choices how to build with dry floodproofing and wet floodproofing. Dry floodproofing, I'll show you here, is where you basically build the lower level of material that can absorb the water and dry out and still be reusable so your structure stays intact. And then the floors above, the second floor can be built with conventional framing. Wet floodproofing is when you would do things like build with framing, but knowing it's going to get wet, install the drywall, not vertically 4x8, but horizontally. So if they get flooding in space, you can remove the bottom half of the drywall, address the drying procedures, and then put back the drywall at the bottom and not have to take out the drywall at the top. Obviously, dry floodproofing is much more effective than wet floodproofing and makes a big difference. And then earthquake resistance is really critical on the western seaboard, almost from California to Washington and certain other concentrated areas. And we know how to do this: lateral stiffness and strength, regularity and movement, redundancy allows different pathways for the lateral stresses imposed by the earthquake to be absorbed, strong, secure foundations, and again, a continuous load path. And we know how to apply this. Just by design, we can radically improve the earthquake resistance of a building, having a much stronger base and flimsy foundations and posts at the bottom, having a continuity in the shear plane. So instead of having windows that are not stacked, you stack the windows, and having the shear walls line up. So instead of having step designs, all the shear walls top to bottom can transfer the loads. So we can design for earthquakes and have much lower risk. And then winter storms, the big damage is from either the weight of the snow that can cause structural damage, or if warm temperatures warm enough to start melting the snow, accumulating on the roof, allow it to melt down and freeze after it gets to the edge, you have the risk of ice damming and all the damage that can do. So the best practices are heavy membrane moisture barriers at eaves and valleys. If we have unvented attics, like SIP roofs, you want a vapor diffusion port at the ridge, potentially an air gap between the surface of the unvented attic sheathing and then the sheathing for the roofing material itself that allows cool temperatures to flow beneath the roofing so that the snow accumulating doesn't melt. And then vented attics, no heating equipment and ducts in the attic, minimizing recessed lights that can let heat get up into the attic and create melting. Insulated sealed access doors and panels that minimize heat flow to the attic, and insulation above plumbing to protect it from freezing. So basic stuff we know that's tried and true. And after the event, essentially we have best practices for how we could stay in our home. The first is resilient comfort. We talk about natural comfort and high performance homes in Housing 2.0. They basically reduce the heat gain, heat losses, so buildings float and stay more comfortable. And then after an event, what are you going to do for power? So renewable, on-site and microgrids, batteries, having panels that will break up, so you have priority loads that can help you stay in the home and not have to serve all the loads, and also being grid interactive so you can shut off when you need to and everything works. JD will cover this at the end of this session today. And lastly, what I want to say about resilience is we can make choices that complement or conflict. So for wildfires, we talk about unvented attics, unvented crawl spaces, non-combustible materials versus vented attics, vented crawl spaces, combustible materials. I don't want to go through this entire chart. It's in Housing 2.0 book, but what I want to highlight is that for wildfires, high wind, and floods, virtually all frame construction, conventional frame construction, wood and vented attics and unvented and wood frame walls are much higher risk compared to concrete construction. So what winds up happening is here's a company, Onyx, that makes these advanced manufactured wall assemblies. It's a double concrete wall sandwiched around insulation, and it is so disaster resistant. In Florida, they self-insure. So it winds up that their customers save thousands of dollars a year and have access to insurance. What a huge advantage. And they generate, $5,000, $6,000, $7,000 a year of income per home in perpetuity after the home, because their homeowners are paying them the insurance on an incredibly low risk product. So it's incredibly profitable to build an appropriate high resilient design solution. So we talk about them when we have sessions on Housing 2.0 applied and how profitable it is to builders. But essentially just optimizing resilience does amazing business outcomes for this particular offsite builder. And again, I want to close just by saying this just came up on my, I found this last week, that AlfGeo now has a web tool where you go in and you put in your county. I put in my county, Fairfax, Virginia, and you can see how much risk you have. And virtually very low risk for hurricanes and wildfires, low risk for coastal flooding and drought, medium risk for heat, and high risk for inland flooding. So what I did to manage my risk is I chose a very flood resistant location. You'd have to have a 40-foot rise in water to even come close to impacting my house. But basically, this will inform consumers. The impact in the article covering this new resource said, as buyers and sellers wake up to risks on a hotter planet, millions of homeowners throughout the country could face a slow and almost imperceptible repricing of many people's biggest asset. So hopefully many of you will get the point. Disaster resistance is not extra credit. It's a must-have today. It's the future we know with certainty. Next, future ready is water efficient. And so again, I'm going to start with Housing 2.0 best practices for how do we truly optimize water efficient homes. And the high tier best practices optimize water use indoors, outdoors, and also water harvesting. And so indoors, it's about water efficient fixtures and appliances and hot water distribution. Outdoors, it's about irrigation and irrigation controls. Water harvesting has two options: gray water recovery and roof water collection systems. So this quote from Ben Franklin back in the 1770s has only gotten exponentially more relevant. We will all know the value of water when the well runs dry, and suggests that maybe the well is running dry. This new study suggests 71% of the nearly 1,900 aquifer systems globally had declining groundwater levels between 2000 and 2022. So this is a global issue. And as we're marching towards 9 billion people by 2050, 11 billion people on the planet by 2100, and water demands keep getting greater, saltwater intrusion keeps getting greater, contamination of water aquifers keeps getting greater. It is just a tsunami effect waiting to happen. Water is just going to be one of the most major issues of our lifetimes. And so we start seeing the impacts just when we look around us. The feds call for water cutbacks to avoid a catastrophic collapse of the Colorado River. There's a 23-year drought that's been drying up the river, and it's been attributed to extreme heat, low precipitation from climate change. We don't care if it's human impacts, we don't care if we believe in climate change. What we care about is hard data, and there's been 20 years of heat and drought, and we have to prepare for that hard trend. And so when you look at the map of the country, you see that the water imperative is kind of regional. You have massive amount of water resources just from a little bit from east of the Rockies all the way to the coast. You have all these, abundant water flow systems that are being tapped for water supplies, notwithstanding, again, some of the issues with contamination that we keep imposing on this water supply. But when you go west of the Rockies, it gets pretty scary. There's virtually, from Oregon down, from southern Oregon down, virtually, it is that Colorado River that has to bear the brunt of getting water to so many people. You have the San Joaquin River up in California, but by and by, it's the water that's stored every year up in the Sierra Mountains that California relies on for ever-growing demand for water. And of course, we see so many times California goes into 6, 8, 10-year droughts, and that key supply system is not reliable. So you look at the water risk everywhere west of the Rocky, and you realize this is where we're building homes. California, Nevada, Arizona, Texas, and then you look at where the risk is getting worse and worse in the country. The water risk by 2015, the areas that will have extreme risk are that same area that has so little water resources. On top of that, Florida has this big risk because of so much saltwater intrusion into the aquifers and so many forces that are also just due to growth that are really putting a strain on their water supply infrastructure. Consider this one example of just how much risk we have. $40,000 a door just to have the right to water to build in Colorado. I forget which location that was, but it's just really a major issue that I don't think enough people spend enough time with. And these solutions are so simple. Indoors, everyone should be using WaterSense fixtures, showers, faucets, toilets. They keep getting better and better, and they perform great. That should be a no-brainer. And then Energy Star appliances also use significantly less water, dishwashers and clothes washers. So that should be an easy no-brainer. Every builder should be using WaterSense fixtures and Energy Star appliances that have dramatically lower water needs. But then comes water distribution, hot water distribution. And if we look at the amount of copper piping just in a fairly small house with a fairly small layout, it's about 1.6 gallons, and you have to wait at the ends of the system up to almost 2 minutes to get hot water. So all the water running being wasted as we wait for hot water is a huge impact on water use. So what can we do to improve hot water distribution? So we can have a core layout or manifold that work fairly similarly. From the hot water heater, you're having direct runs to the fixtures. This is with a manifold device. This is just how the plumbing is getting set up. Or we can do compact plumbing where we get the fixtures much closer to the hot water heater, sometimes with a wet wall, or we can have demand initiated recirculation with something called structured plumbing. I'll kind of walk you through these one at a time. So a manifold system's pretty simple. Within 10 feet of the hot water heater, you set up a manifold. So you do home runs to each fixture. So each fixture, you're not waiting for water to go through the whole system. When you get to the outer fixtures, you kind of have a direct run and use a lot less hot water. The other thing you can do is compact layouts. Here's non-compact layouts that you will commonly see. My good friend Gary Klein developed this system, compact plumbing, which is great. It's something I kind of spent a lot of time with early in my career as an architect, and I really love to see him just bring this to the forefront. But you can see in a typical house, this is 3 bedrooms, 2 baths, maybe 1,500 square feet, with a water heater in the garage and fixtures on this wall and fixtures out here and fixtures out here. The square that you would draw to cover the area responsible or area that requires plumbing in the house, it would be 67% in this case. And this little bigger design that's about 1,800 square feet, again with the water heater in the garage, plumbing on the extremities, all around. When I draw a rectangle around all the plumbing needs, it's 81% of the house, very uncompact. My recommendation is to build on Gary's work, but suggest maybe we don't need to worry about, for instance, the kitchen and laundry. Because when we go to wash dishes and turn on the hot water, we have plenty to do to rinse the dishes, and it's not an issue. We're not sitting there waiting for hot water. We're really using the water for full purpose, just cleaning and scrubbing the dishes. Or laundry machines will get hot enough when they first draw the water and eventually get hot water into the load. And so I recommend, for instance, you just, in this layout on the right, this is all the bedrooms. I should be worried about getting this water heater closer to this location where all the bedrooms are, because that's where you tend to really run the water in the morning, waiting for the shower to get hot, with the sink to get hot so you can shave or wash. So I would say the 80-20 rule. Worry about the 20% that gives you 80% of the outcome. Just the bedrooms are the most important to me. And so when I look at this project that Gary did, where he had a Habitat for Humanity home that was about 1,300 square foot in the right, and he asked a good water expert friend of his to make this more water efficient, to see if it can improve on this 79% compact plumbing square. He got it down to about 2.5%. He put bathrooms back to back in the kitchen, and that was pretty impressive, but not to me. Look at how compromised this house got compared to the first. The kitchen is a horribly less effective kitchen with a very limited access to the backyard now for the kitchen instead of for the main living space. The bathroom has no access to daylight. You have all this wasted space here. I don't know what you do with when you come in. It's just such a less quality design for the user experience. You can't do all that and take out the plumbing. So I go back to the first layout and I just move the water heater to this closet. I'll go back here, this closet here, and I can basically get an 8%. So again, you want a much more simple approaches. I'm not worried about the sink in the kitchen. Here's a layout I did before Gary invented compact plumbing. I was working on a project in 1984, but I added water efficiency just to my list of criteria for good design. And you can see I was able to get the master bath and the hall bath, the laundry and the kitchen all in this one wet wall. So it was amazing. About 5% was the plumbing square. Note this bathroom here, I wouldn't even put hot water there. I just put an instantaneous heater at a lavatory because it's used so infrequently, and you might as well just have a small little heater in the cabinet below. So again, you think about these, but recognize Gary quantifies you can get up to $2,000 savings with in plumbing installation and materials by going from very uncompact to compact. And when you see a wet wall done effectively, you can see why. You know, all the plumbing is in this one wall. You can get it done with so much less labor and material. In the case of systems built offsite homes, it'd be amazing that you can ship a whole core, build this in a plant and ship it, and have your plumbing and bathrooms all done in the plant at much lower cost. And you get some really substantial savings. High efficient water heating on demand is where you run structured plumbing from a water heater, which means you go in sequence to all the fixtures and showers and everything in the house. And once you go in sequence, then you add a dedicated return from the last most remote fixture back to the water heater. And it goes through a receiver and a demand pump that are activated by control. So when you need hot water at any fixture in the house, it activates, the receiver picks up the signal, the pump activates in 10 to 15, 20 seconds. When you turn on the fixture, you have instant hot water and no waste. So another way to go. Outboard or outdoors, water efficiency can be done with efficient landscapes, irrigation, and reuse, recapture. That's up to 50% outdoor water loss due to inefficient irrigation. About 30+% of total water use is attributed to outdoor water use, but in arid climates like California, Arizona, Texas, it's up to 60%. So for landscape design, we have to think more about xeriscaping, low water native plants, minimizing turf, mulching planting beds so they trap the moisture, vegetate slopes to minimize runoff. A lot of solutions to really good, efficient landscape designs. Irrigation is drip irrigation, weather-based irrigation controllers, and soil-based irrigation controllers that sense the moisture. And we talked about gray water and rainwater harvesting. So gray water basically takes the water from tubs, sinks, and clothes washers, collects it in a surge tank, and you can meet about 50% of your property's water needs with gray water. The water used for kitchens and toilets goes right into the sewer outlets, but essentially you're capturing the other gray water that is good enough quality to use for irrigation and getting all that use out of it. In the case of water harvesting, this is the wrong title on the slide. Okay, never mind, I'm out of sequence. I want to talk about water harvesting first. Water harvesting is when you use your roof as a roof design to collect the water most efficiently, and then you put it in a tank. So you wind up with everything is better because instead of hard water, which is endemic to so many locations, you have 100% soft water, free of salts, minerals, treatment chemicals, and pharmaceuticals found in municipal water, groundwater, and surface water. So it's amazingly high quality water. And you can collect 620 gallons for every inch of rain. So let's say you get 20 inches of rain a year, that's 3,000 gallons of water. And if you have 2,000 square feet of roof, that's 6,000 gallons of water. So, you know, it's a lot of water you can collect, and then you have, now you have to treat it. So basically, there are a whole bunch of components you have, you know, filters and diverters and a little bit of meters and ways of just really controlling and making it high quality water. Going back, I want to just get back to this concept that not only is water use using a very short availability resource. I mean, water is declining so much in terms of blue water that's really high quality enough for potability. But on top of a material or a resource that's in such decline, it also is a significant energy consumer. We all know about using water for heating and hot water, and so if we use less hot water, we heat less hot water. But also there's energy used to extract water from a resource, from an aquifer, from a lake, a river, or a reservoir. Then you have to convey the water from that source to a water treatment location. You have to spend energy to treat the water, then spend energy often to pump the water throughout the local municipality to get it to each of the homes and distribute it. And then you have to collect the water after it's used in the house and often pump it back to a water treatment plant, have the treatment plant use energy to do the treatment before it's released back into a river or stream, wherever it may be. And there's all this energy being used. So EPA calculations suggest water conservation is the cheapest source of energy savings. Insulation, airtightness, this is per dollar spent supposed to be the lowest cost of energy efficiency. Okay, on to the last module, and we're going into smart all electric is the future. And again, the Housing 2.0 best practices for smart, efficient homes are shown here. Again, the high tier best practices are optimizing comfort, water heating components, smart capabilities, and electric ready. And again, the more granular solutions for comfort are efficient smart equipment, along with design and installation. For water heating, sufficient smart water heater plus proper water heater installation. For components, it's the appliances, lighting, and fans. For smart, it's smart home integration. And then for electric ready, looking at our gas oil devices, if we choose to still use those, and make them ready to transition to electric in the future by providing high amp outlets instead of 15, maybe 20, 30 amp outlet at the location to avoid disruption and costs in the future if we want to go from a gas cooktop to an induction cooktop, for instance. And solar ready, we'll talk about in a few slides, electric ready as well, battery ready, and grid integration. So it's really great to get efficient appliances and look with Energy Star, but you should always look when you buy these appliances to make sure they're smart ready as well. They can integrate with smart systems and controls so you can manage them more effectively. Here's examples of also some amazing innovation that's happening with high performance appliances. This is a vacuum insulated panel refrigerator. A vacuum insulated panel might be 10 to 30 per inch compared to 3 or 4 per inch or 5 per inch. It's incredibly more effective. So it's 50% more efficient, but it has 66% thinner walls. So you have 25% more capacity per same size refrigerator. So it's amazing how great an application this is for vacuum insulated panels. Originally, they're being focused on for cladding homes in a retrofit. So without adding a lot of thickness, you can make an existing home much more insulated, closer to what we currently do with the latest codes. But this is a great application for vacuum insulated panels because you don't have to worry about penetrations and that could undermine the performance of the vacuum itself. On top of that, heat pump water heaters are a great new innovation. Ducted heat pump water heaters now give you a way to put them indoors with less impact, having to manage the waste cooling. They're particularly great in hot, humid climates where the waste cooling can be useful. And then as you get colder and colder climates, ducting can be a huge solution. In absence of ducting, you need a lot of volume to allow the unit to shed the waste cooling that comes off it. And you want using more backup electric heating in these colder climates. So water's coming in much colder, and there'll be periods where backup heating will be more necessary. And in cold climates, you have to worry about the additional penetrations through the wall with the venting do create thermal holes in the assembly. Heat pump washer dryers are an exciting new innovation. So one appliance, you have both the clothes washer and the clothes dryer, and you have no vent because the way the dryer dries is all the water is exchanged and dumped through the same vent that the clothes washer vent goes through. So it's a elegant technology. There's no necessary user requirement to take the clothes from the clothes washer and put them into a clothes dryer. So it's a huge benefit to the occupant. It's ventless drying because again, it dries without exhausting the humidity, but exchanging it and exhausting it through a drain. Half the space because you don't need a washer and a dryer, about 50% energy savings and really large capacity loads. So this is a real exciting new device. It saves space, it works better, it's an amazing innovation. And then there's induction cooktops I mentioned earlier. They use magnetic inductions with ferrous iron cookware to transfer heat without heating the surface itself, the cooktop, but the cooking vessel, the ferrous iron cookware, and it's an amazing cooking. It's precise, it's faster than gas for boiling water and heating. It's really just safer. It's every way it's a better user experience. So these are the current way induction cooktops work in cabinets, but you don't really need you don't need a cooktop surface. When you have, let's say, like granite counters or stone counters, you can just put the cookware directly on top of the counter and have the induction um, uh, devices below the counter to transfer the magnetic current and heat the vessel. So you wind up with all this extra counter space because you don't need a cooktop surface anymore, just this place for the controls. Again, it's really elegant. Also, the one device that people worry about what they do without gas is fireplaces. And I'd say look at some of these new electric fireplaces. They're pretty impressive. This is a holographic fireplace that just really has a great way to replicate a traditional fireplace. This is one that's still done with moisture to create again, mimic a fireplace look and feel. So you have lots of options for how you can integrate fireplaces that will increase over time. And then again, smart components like exhaust fans that know what to do and sense moisture and people and just work more efficiently. This is our good friends from Panasonic. And then this brings us to smart homes in general, why we do them. And it's because it's such a great user experience, and it's a rising expectation among home buyers. They want all the convenience, they want all the protection, they want the ability to operate more effectively all their equipment and access all the entertainment. I'm not going to go through all these, but you can see essentially there's a lot of just incredibly enhanced ability to use all facets of your home with a comprehensive approach to smart homes. And so basically what I show you first is a definition, since a lot of people aren't sure what a smart home is. It's a home that incorporates automation systems to provide inhabitants with often the utility company with sophisticated monitoring and control over the building's functions. And so that includes energy management, lighting, glass breakage, entry, motion detection, alarm activation, professional monitoring, keyless entry, live video streaming to monitor your home, blinds and all the window blinds, temperature controls, remote control of appliances. You have just like massive greater ability to use all facets of your home. And so to get there, basically, we have to think of integrating a lot more components in our home. You need a portal that's smart and can take all the signals and then make everything operate properly. You need to have integrated devices that receive signals. I mentioned the appliances and equipment and components. You need to add cameras, sensors, controls. You need a dashboard for the homeowners, which often can be the smartphone. And you need a special app for getting everything to operate effectively. And then you have to start somewhere. And most people are overwhelmed when they think about going smart. So there are various steps to getting more and more convenience and control. Partial integration are devices that have inherent connectivity. A lot of times, do-it-yourself abilities for people who own the home just to set up lights or ring doorbell so they can see who's coming to the house or operate a light switch conveniently. So it's just kind of getting your foot in the water with just some smart capabilities. And then you go to limited integration where the devices are set up, the much more effective controls fully integrated, and professionals are install them so everything works much more seamlessly and with one integrated system. Full integrated integrations where you have remote access available to all your devices. Multiple devices are integrated in one platform and not a ring doorbell and a separate device for your lighting switches and a separate one for your heating cooling system. Everything's integrated and it's a full-featured smart home. And in the future, we'll get more predictive and proactive automation where homes can learn and an automated way really anticipate and function at a higher level. So we have all these capabilities, and then we're smart. For now, to be electric ready, I'm going to go through this list one more time. For gas and oil devices, high amp outlets, things like gas cooktops, ovens, clothes dryers, furnaces, and water heaters. Just have those higher amp outlets there so you can transition to electric if you don't want to make the house all electric now. Solar ready, I'm going to show you a diagram that's more detailed. Same with, well, EV ready is having a high amp conduit for high amp outlet and a level 2 ready outlet. Batteries is a bus bar for the key priority loads, backup power circuits, transfer switches, and sub panels, and grid integrations, a smart meter. Why we do all this is because this is the future. We look at solar ready. We know the cost of solar will keep coming down. Let's make it so without disruption or cost penalty, we can add all these newer, better, higher efficient solar systems that are coming. Here's one innovation that promises 1,000x greater efficiency cells using new materials. We'll see if that comes around or not. Here's how you make a house solar ready. It's so simple. You can do this for hundreds of dollars and avoid thousands of dollars of cost for installing solar in the future without disruption. So the first thing you want to do is make sure you have the documentation that the roof, truss system, or framing system can handle the 6 pounds per square foot additional load of the solar collectors. So just give the homeowner the structural certified drawing that says the roof can do this, and it saves them all the cost of getting an engineer and going through the burden of getting this to the building department. Then have conduit from the attic, most often to someplace near the circuit board. Have a dedicated area next to the circuit breaker in case you need to have a separate inverter instead of microinverters. Have a circuit breaker with extra circuits for the solar system ready to go, and then a conduit from that circuit breaker to that extra dedicated area for the inverter. And it's so low cost to add these extra components. The electric ready, battery ready home. In addition to the solar inverter, you have the main panel and you have the backup gateway for the prioritized loads, and also working with the utility meter, and the battery storage can then go and take care of the priority loads when you need it. And with all the switching, JD's going to do a much better job than me laying out basically how to get your house with an elegant solution that's so much more aesthetic than just having all these individual components. And in the end, this is the certain future. It's smart, it's solar ready, it's battery, it's EVs. We know we're going to this. These are what homes will look like in the future. Let's be ready for it. And I'll wrap up with this final comment. Every time I think about the times and stress, it's always because I believe I'm not prepared. I don't know my speech. I don't know how to do work with that app to get it to do what I want it to do. Whatever it is, what's driving stress is when I'm not prepared. So I'm going to suggest future ready recommendations. Prepare for accelerating disaster risks. Prepare for accelerating water crises in the locations that are the greatest risk. And prepare for accelerating smart, all-electric expectations because they deliver such a superior user experience. And I'll wrap up by saying, and people will say as they look upon their homes that stand the test of time, see, this our builders did for us. So hopefully this makes sense. And I'm so happy to hand off to JD Gill because he does a great job with some amazing solutions for elegantly making your houses smart. Thank you so much.
Thanks, Sam.
All right, thank you. On over to JD.
All right. Let me see.
Looking good.
You can see my presentation?
Yes.
All right, perfect. All right, good morning, everyone. My name is JD Gill. I'm with Schneider Electric. And if you don't know who Schneider is, we specialize in digital automation and energy management. In terms of the residential space, we are in 4 out of 10 homes. So it's possible that you're likely using us today already, right? So we often go by the name of brand name of Square D. And today we'll be talking about and kind of going off of what Sam was talking about, right, in terms of future ready, defining what smart energy is, and Sam was touching on some of those key points, especially as we move into this new energy landscape. So first, I just want to define what smart energy is, just level set us, right, because really this is going to be that gateway to being future ready. So first part is home electrification, and again, Sam was touching on this, stealing some of my thunder, right? But moving from your traditional gas appliances to all electric, so your stovetops to induction stovetops, your water heaters to electric and heat pump water heaters, right? So really moving to all electric, getting rid of those gas resources. Next step is battery energy storage systems, or BESS systems. So battery, there's a couple different ways you can use this. So one is, reliance, and that was a key point in Sam's discussion too, right? Wildfires in California, we have the hurricanes out east. Texas had that crazy winter storm a few years ago. These traditional black swan events are not becoming, they're becoming more and more common. So they're not really those black swan events anymore. So resiliency is becoming more and more of a priority and a need for home builders, or for home builders as well as homeowners. And then the other side of batteries is the cost effectiveness, right? So you can use your battery store, especially when it's paired with solar, and or just charging from the grid during times when the rates are low, and then selling that battery back to the grid when you're on maybe time of use rates from 4 to 9 p.m., for example, and or using that battery during those times when rates are high, so that way you're not paying those exorbitant fees. So a lot of flexibility there. Last piece here is home energy management systems, or HEMS. So really, this is kind of taking all of your home's electrical parts and pieces from grid all the way down to the plug and simplifying it, helping the homeowner automate it. This can be done using monitoring, control, right? Really trying to view what that home is consuming versus producing, and maximize savings with the local utility and their rates and all that. So let's talk about ways you as a home builder can satisfy this demand of smart energy, right? So we're going to start all the way from just kind of your basic smart ready homes all the way up to community microgrids. So when we're talking about a basic smart ready home, Sam was mentioning some of this, right? And you guys might be building this already. If you're putting in a square D panel, and even most panels these days they're solar ready, right? So your electrical panel is ready for solar. So if the homeowner wants to add solar later, or if you're offering it as an option, they could add it there relatively easily. Next, we have how do we become battery ready? So typically, when you have one battery on a home, it's not necessarily enough capacity for one battery to outlast a multiple day outage, or multiple day storm, right? One battery typically will, they say one battery is about 10 kilowatt hours, which is about 1/3 of your day's worth of energy consumption on average, right? So obviously the homeowner can add more batteries, but just level set with them in terms of expectations. But how do you become battery ready? Typically you have your main panel, and then you can have a critical loads panel right next to it. So essentially, in order to preserve that battery and have it last longer than that typical day, you can just have your major loads like your lighting, refrigeration, internet, right? Things like that are truly essential for home comfort, and put those loads in that critical panel, and then all the other loads in the main panel. Again, for EV charger ready, right? Wire conduit coming out of the panel. If you want to include that 50 amp, 60 amp breaker in the panel as well, your home can be designated as EV ready as well. And then from there, we have other options of, adding energy monitoring. So really giving the homeowner a view into how they're using their energy, when they're using their energy, and how they could really maximize their efficiencies, especially when you tie in the utility rates, into that energy monitoring. Folks can see, hey, my water bill or my water heater, maybe I shouldn't take showers at 5 p.m. when, my water heater is going. So you can either shift your usage into a different time of the day, and or rely on the battery backup, or even using control via both at the panel level and at the room level. So control via controllable relays at the panel. So switching that water heater off from 4 to 9 p.m. and or just controlling the lights, the receptacles, right? The switches, dimmers, things like that. All that can be connected as well. So yeah, kind of what that looks like, sub panels, your breakers for EV, and again, those smart pieces via energy monitoring and control. So next step is a full smart home. So we take kind of all what we talked about in that basic smart ready home and packaging it into really almost one enclosure. So you have your critical loads panel, backup panel. You have your backup control switch, right? So this is what's going to detect if your utility is there, switch it over to your battery backup, right? All these parts and pieces are combined and essentially creating a nano grid in the home, right? So this is kind of one of our solutions. Many other solutions outside of this, but this is our new Schneider Home suite of products. But this is the pulse panel. Again, this is going to be your critical loads panel as well as your backup loads. Including that energy monitoring, including the surge protection, those connected relays, anything that you need for that home to be smart. Lastly here, taking it a step further, right? So each home could be a nanogrid, but now how do we, we're building communities typically as builders, right? So how do we make that community more energy resilient? So, you could have a community battery, you could have a community solar, right? So with this, instead of outlasting for maybe a day or so in a single family home, as a community, having a community battery and solar, you can outlast these outages for days, not just days, but up to weeks, right? So the community batteries are going to have powered not only through the homes but through that community solar as well. And on the other side, there's a revenue generating options for these communities as well, right? So VPP programs, virtual power plants, what that stands for. So essentially, the community can sell off their excess power during the day to utility and/or when the utilities have that demand for peak power. Usually in the afternoon times when folks are running their ACs, right? So community microgrids are often thought about like, oh, hey, that's just way too expensive to implement, but there's a lot of things that we could put in place, with Schneider Electric to offset a lot of those costs. And just a quick view on what that would look like, right? So here on the left side, you have your renewable energy sources like solar, wind, perhaps even a generator for that extra backup. Then on the right side, you have your traditional utility. You can have energy storage for that community, right? The load here is the community itself. And then EV vehicles is an interesting one, right? Traditionally, when we think of EVs, we think about charging the EVs and driving them around. But now we have bidirectional charging as well, right? So meaning taking that big battery from the EV, right, which is usually about 10x what a home battery would be, and using that as a backup to your home. So kind of that's why we call it bidirectional. So you can not only charge the EVs, but send that EV power to the home as well. And really in the center of everything, right, the controls and services of Schneider Electric, that's going to help operate all these parts and pieces together. So that's largely what I had today. Please feel free to reach out to me with any questions. If you're interested in any of these products, I work with the home builders nationally. So just want to help you guys, in any way we can.
Thanks, JD. Appreciate it much. And if you do have questions, please send them in to the chat box for JD or for Sam. JD, I've got a couple that have been on my mind since I last got a chance to talk with you. On the community battery that you just talked about, is there like a limit as to how much can be pulled out of that during an outage per user or subscriber? Because I could see a situation where there's an outage and I'm just going to let my house keep running as normal and suck a ton of power out of that battery, versus others who might be like, well, I'm just going to go to critical load only.
Yeah, no, that's a great question. And I think when we're designing these communities, we can put those measures in place so that one person isn't hogging all the energy, so to speak, right? So, we've built our first community microgrid out in Menifee, California, with KB Home. So, kind of what we're doing there is, this panel that we showed here today on the presentation, there was a predecessor for that panel. It still had that kind of split bus, right? So the critical loads, the backed up loads, right, for the home, those were essentially the same for all those community members, right? So there wasn't one person that had their hot tub on the backup or anything like that, right? So it's just, again, your essential loads, so that in need of a true emergency, you have lights, you have refrigeration, you have your internet, right? Your core essential needs. So yeah, so we could definitely implement that in ways, not only just by where we place the breakers in the panel, but also using those controllable relays that I talked about. We can use those relays to, from the back end, turn off those relays. So if they do have, let's say, maybe their AC on their backup, right? And the community battery just won't allow for everybody to have their AC on at that time. Those controls and systems that I was talking about, they could actually just turn off the relays from the back end, so that way everybody's kind of on a level playing field.
Okay, good. The other question that I had was, I'm just curious as to how the system knows there is an outage.
Yeah, so I mean that. Oh, sorry, go ahead.
Utility today, and they were telling me about how they can send me a notification by email, and I was like, oh, okay, that makes sense. But I'm assuming the system doesn't get emails, so I'm just curious how it works.
Yeah, no, that's a great question. I mean, sure, we definitely get emails if there's going to be a known outage, right? So we can plan and prep for that. But again, when there's wildfires or hurricanes rolling through, that power may or may not be there. We just don't know, right? So the community one can just have that battery charged up fully, especially if they see that storm coming in, for example. But how does it know? So it's just really the systems that are in place. So like what we call it, you can call it an automatic transfer switch. The device that's detecting that utility power that's coming in, it can sense in milliseconds, right? If that utility power cuts off, and then it can immediately switch over to that backup. So there's smaller ATSs, like I showed, like that fit in this small panel in your home, or there's larger sizes that would work for a community as well. So varying sizes of automatic transfer.
And then one follow-up to that is, let's say you have a PV system on your home that it's a nice day out, so you wouldn't normally expect to have an outage on a nice day, but you have a nice day out, and your system is maybe producing slightly more power than you're consuming. Mm-hmm. It's still able to detect an inflow of power from the grid, even though the property is technically not pulling any power off the grid in that scenario?
Yeah, so the way a lot of the solar systems work is they're usually called grid-tied systems. So yeah, the solar, if it's producing extra, it's going to pump it out to the grid and or your battery to store it for later. But because it is grid-tied, that system is constantly looking at that utility power to see if it's there, because traditional solar is just not going to work on its own if there's no grid. That's the true meaning of grid-tied solar. That's why when you have add that backup controller or backup ATS, that's going to be the true piece that's going to detect true piece that's going to allow you to switch over to that battery backup.
Okay, all right. And we did have a question come in from our friend Zoran, who's up in Canada. He was expressing dismay and frustration with, apparently the Canadian Home Builders Association has just removed the energy monitoring requirement for their net zero home program. Are you aware of that, JD?
I'm not. I don't deal with Canada too much, but I do have counterparts that I could definitely put them in touch with. But I have not heard of that myself.
Okay. That's a little bit surprising there, but
yeah, it is.
I wanted to get to a couple of other questions that came in, and this one I think really is germane to both Sam and JD. So I'll ask it kind of to both of you. It came in from Brenda. She wants to know, how do renters make the necessary changes for water or energy savings if they can't control the items in the house?
Do you want me to go first, Sam, or do you want to go?
Yeah, I'll take it. Essentially, okay. Renters are not in control of the physical structure they live in. They're renting as is. And so all they can do is basically put requests into the building owner, whoever owns a home or apartment to make improvements. So, but as a renter, you can choose to have behaviors that reduce energy use in the home. You could use LED lighting instead. You could switch your uses to off-peak to the degree there's off-peak power. There's things you can do, but you have very limited options if you're renting to improve the property, because you're not going to benefit from the physical improvements. The asset's owned by somebody else.
Yeah, no, that's a great point, Sam. And I think it depends on if we're talking about existing buildings versus built to rent, right? So if we're talking about built to rent, obviously we can incorporate a lot of these energy monitoring tactics right at the time of build, even if it is for renters. We have fleet management type of programs that the owners of that facility can look at, break down the electrical usage of each tenant. But yeah, in a retrofit style or sense, it is a lot more limited, obviously, because the owners may not allow any major infrastructural changes, right? But if they do, the owners want to make some changes, for the betterment of the renters. Schneider has some aftermarket programs. I know there's aftermarket parts and pieces that other companies do as well. So it's not to say that it can't be done, but it has to be kind of willed on by the owners of that place.
Yeah.
And then one other question for the both of you. This came in from Zoran, and so it's a little bit of you get to share your philosophical prediction and outview into the future. Is the transition to all electric going to happen in our lifetime? Is there enough electricity to replace fossil fuels for cars and homes? So Sam, you went first last time. We'll let JD go first this time.
Yeah, no, I think we're definitely seeing that, right? So especially, I'm living here in California, so we're seeing that trend to all electric. It's not completely, switched over, but it's happening. It's especially like those induction stovetops we talked about, right? People always say, oh, I'm going to miss gas for my cooking, but those induction stovetops are equally as good, right? So I think just the mind block of homeowners switching, I think we're eventually going to get over that. To address the second part of that question, do we have enough electricity, right? I think as we adopt more solar, which, again, in California, every new home solar is mandated on, right, to help with the increasing energy needs that we're going to have all the way up to into 2050, even into 2100, right? So I think our policies need to change, as well as our building policies need to change as we electrify more. Having solar standard maybe across certain states where that solar energy is abundant, right? So I think we do have enough, and it's really when we use our energy is going to be really key, right? So maybe we're all charging our EVs at night, and then maybe pumping that same energy that we charge our EVs with if we're working from home into our home during the day. So I think there's a lot of tricks and things that we could do. But yeah, there's definitely a need for more solar generation, whether it's via solar or wind or other renewable sources.
Yeah, I think it's a great answer. If I would just build on it just a little bit, I believe all electrics for new construction is well within the next decade. And the reason for that is because everyone who knows me from my Housing 2.0 program and other work, I'm just driven by the belief that a better user experience at lower costs will triumph. And when you look at the cost of having to build the infrastructure to get gas to all these locations, and then have devices that work faster, better, cheaper that are electric, it just, to me, eventually sanity takes hold and people just make the choices. So again, we can go device by device, but an induction cooktop is faster, better, safer. It's precise control. It boils water faster. When you pull a vessel off the surface, if anyone touches the surface, it's safe to touch because it's only the vessel that's hot. And it just cooks more evenly. And you have less emissions in your house. There's no, I know we can put vents for stoves, and but we just don't vent as a as a housing public out there adequately. Emissions are a real issue from cooking. And I think we want all those benefits. And so we're going to go to induction cooktops just because it's a better experience. Same thing with fireplaces. They're drafts. They create holes to the outside. They disrupt the comfort of the room. And if we can create devices that are precise, have more visual capabilities and choices and convenient and don't have emissions, it's just a better experience. So all these things, we can go device by device. And then because of smart systems now, all these devices can now be more effectively used than any gas device, because they can be hooked up to our smart integrated system. So yeah, because of that, cost savings and everything else. And then, there are bigger issues people worry about with gas infrastructure and safety and so forth. So that's the first part of the question. The second part, of course, is that we can use our resources and assets so much more efficiently. Particularly if we start making batteries standard in homes and use off-peak hours to charge them. And then we start adding, as JD said, more and more renewable capacity to the grid. It's just, there's nothing I've read that suggests there's a shortage of electrical resource that can't manage this all electric future. So we have plenty of resources, and even we can build up some of the natural gas plants that might fill as a transition. There's more and more interest in nuclear non-emission plants, also at Department of Energy. So we'll see how it plays out. But I think in both cases, innovation will rule the day, and we're going all electric.
Sam, I wanted to reinforce one thing you talked about earlier in the water section when you were talking about Gary's compact plumbing. Two other things to add on that would be, one, you were talking about in the kitchen sink. Pot filling is another one. So you're washing dishes, but also when you're filling pots, it doesn't have to be instantly hot right away. It will get there. Plus, you're going to heat it up anyway. And then in the laundry, there's a lot of detergents that are now being designed to be used with cold water. So again, another reason why you don't have to have the instant hot water for the washer. And then the final thing I want, what's that?
I agree. Those are good points.
Yeah. And then the final thing I wanted to share with our audience was a free resource that is available through IAPMO. It's called the Water Demand Calculator. And this is a tool, again, it's free. Anybody can download this in the app stores. I believe it might also be on their website. But it's a tool that helps you to right-size the pipe coming in from the main to the house. And just right-sizing that alone can save you a few $100s on a single-family project. And if you're doing any multifamily, it can actually save you thousands and thousands of dollars. So make sure to check that out from the water side of things.
We should also mention a lot of codes are out of date, require piping inside the home larger than necessary. And they're older codes, and we can make the piping smaller, lower cost, less time getting to the fixture. Some of the things are regulatory as well, as you're suggesting, that need to be fixed. Yeah.
Yeah, and JD, you and I saw each other at EBA a few weeks back, and Gary Klein gave a presentation at EBA, and he talked exactly about that, Sam, about, we can make some of these pipes inside the building smaller to get hot water there faster. So, all right. I don't see any other questions right now, so I'm going to go ahead and wrap this one up for today. But hey, we've got one seminar left. It's going to take place next Thursday, November 7th at 12 p.m. Eastern Time. We're going to be talking about community and design, and that's a great concluding topic. I hope you're able to join us. That is always a high demand session. So great topic, great discussions that come out of that as well. But thank all of you so much for attending today. Thank you once again to JD for joining us, for Schneider Electric, Jinko Solar, Panasonic Healthy Indoor Living Solutions, and LG HVAC for their generous sponsorships. Hey, don't forget to change your clocks back this weekend. We fall back 1 hour, and unless you're in Arizona or parts of Indiana. But other than that, yes, fall back. So in the meantime, please stay safe, stay healthy, and take care, everyone. So long.
Thanks.